All right, so a little 5-3B in Advanced Algebra 2. Today we're solving quadratics. And even though we've definitely done this before, some of this we need some memory refresher. So there's three main ways to solve a quadratic. Our very most favorite thing to do is solve quadratic equations. One of those ways is to factor it, but that's not always possible. And we're going to find out that every equation that we got today is not factorable, so there's got to be other ways to do it. One way, besides that, is to complete the square. That does work every time, but sometimes it's a pain in the butt, and sometimes it's really easy. We're only going to do it when it's really easy. We're going to take the smart way for this. And the other way that works every single time is the quadratic formula, which we did a bunch of that in Chapter 3 this year. So that's good. And we'll just realize that sometimes it's a good thing to do, and sometimes it's not a good thing to do. So, best time to factor. Like, when would you solve a quadratic equation to factor? We'll just take a little bit of notes. Well, here's the best time to factor, when you can easily find those two numbers. You know, like when you're supposed to factor, you're supposed to find two numbers and multiply together to be A and add together to be C, all that whatever stuff. So find two numbers. If you can easily find the two numbers, then dude, I'm telling you, factor it. That's the fastest way to do the problem. But on all of the problems that we're going to end up doing next class period, we will not be able to factor them. They're going to turn out to be quadratics that just can't be factored. So we will complete the square, and I know you've done that before, and once I show you how to do it, you'll be like, oh, that thing? That's what you want us to do? But when is the time that we're going to complete the square? When it's easy, and when it's easy is when A is 1 and B is even. If the A value, that's this homeboy right here, the number in front of x squared is 1, and the B value is even, that is totally when we are going to complete the square. Otherwise, we're going to use the quadratic formula. So that's when the numbers are really, really big, so we wouldn't want to factor it, or complete the square. That's what CTS means. It makes no sense. Here we roll. So let's get started. The first one, solve the following quadratic equations by completing the square. Let's realize why. I guarantee you when I show you how to do it, you're like, oh, I can do that. That's no problem. But why are we completing the square? Well, let me tell you. We can't factor it. Can you find two numbers that multiply together to be -10 and add together to be -6? It's not possible. So you have two choices, complete the square or quadratic formula. And I'll tell you the truth, quadratic formula works all the time. But sometimes it's just a pain in the butt. The numbers are so big, you got to simplify all these radicals. So here's how completing the square works. First, we only want to do it if the A value is 1, which it is, and the B value is even. Are you cool with that? So here's how we set it up. Let's set it up with what I call blanks. All the stuff with x's is on the left side with a plus blank. So, and then this constant term right here, this -10, he's got to move to the other side of the equal sign. So what would it become? How do you get it over there? It would be +10, because it is a -10. Don't we need to add it over? But you're going to have to add a plus blank. I'll explain that in a second. So this is the first move in completing the square. You set it up with blanks. Here's why it's called complete the square. We're trying to turn what's in this green box into a perfect square trinomial, which maybe you've heard of before, maybe you have not. But to turn it into a perfect square trinomial, here's all we have to do. Since the A value is 1 and the B value is even, it's a piece of cake. You need half the B value. Could you tell me how much that is right now? What's half the B value? -3. Then you square it. What's -3 squared? 9 goes in this blank. 9 is the number that completed the square, completed the perfect square trinomial. But I think we all know that if you add 9 to one side of the equation, don't you have to add 9 to the other side of the equation to keep it balanced, right? What you do to one side, you got to do to the other. So we filled in that blank, which is very weird, by taking half the B value and squaring it. Then the next move is even weirder, but that's why we got 9 of these in a row to do. I'll bet you we won't need to do all 9 of them either. We'll see how much we can figure it out. But this perfect square trinomial can be factored now. And here's how it will always factor. Put yourself a group of parentheses right here. It'll factor to be the square root of the first dude. Who the heck is the square root of the first dude? What's the square root of x squared? That's just x. And then it'll be the square root of the last dude right here, this +9. What's the square root of 9? 3. But then you got to sneak down the sign from the middle. The sign from the middle is in that minus. So This is the quantity, and if you squared it, that's what this factored into. Like x minus 3 times x minus 3 literally turns out to be x squared minus 6x plus 9. So that is very weird, but we will get used to it. That's a perfect square trinomial. It always factors to be square root of this guy, square root of that guy, sine from the middle, quantity squared. Over here, bro, that's easy. That's 10 plus 9. Would you believe that's 19? So buckle your seatbelts. It's not that difficult. We just got to do a couple of examples. So check this out now. If you notice, we always kind of take a blind eye to what's in parentheses. You're never really allowed to see what's in there. Do you have something squared all by itself on one side of the equal sign over here? That's a beautiful thing, because can't you get rid of that square by square rooting both sides? So let's do that. I'm going to get rid of my block out, though. If we square root both sides, that's going to be a nice thing, because doesn't that square and square root cancel each other out? And what you're left with is x minus 3 right here. And the only thing you got to watch out for is, because you square rooted, you need a plus or minus, and this is the square root of 19. Would you believe the square root of 19 doesn't come out nice at all? Like 19 is not a perfect square, and 19 doesn't even have a perfect square that goes into it to where you could simplify it. You can't even simplify that radical. So nasty answers. That's because this wouldn't factor. If it would factor, you're going to get nice, neat, rational answers. These are irrational. There's only one move left to get x all by itself. I got to get rid of this stupid minus 3. How do you get rid of a minus 3? We're going to add 3 to both sides. Let's put it first, please. And that will be 3 over here, and then you'll have your plus or minus the square root of 19. And as weird as that is totally what the final answer is. There's two answers there. One of them is 3 plus the square root of 19, 3 minus the square root of 19. And I will guarantee you, if you did the quadratic formula on this, you would have got the same thing. But this is faster. You would have had a nasty, big old radical to simplify. You didn't have to simplify any radicals at all. So that was really weird. Let's do another one and get our comfort level up. First of all, do you see how the a value is 1 and the b value is even on this guy? Perfect case to complete the square. You also can't factor it. You can't find two numbers that multiply together to be 10 and add together to be 4. So let's set them up with blanks. All the stuff with x's stay on one side, and then that constant has to move to the other side. So setting them up with blanks. How do you fill in the blank? Half the b value squared. What is half our b value? 2. Square that. What do you get? 4 goes in each blank. That just completed this perfect square trinomial. Now it will always factor into this. Square root of the first guy, now. Square root of the last guy, and the sine from the middle, quantity squared. But because we are extremely bright, I want to show you an even better trick of how that really works. Truthfully, this number right here is always half your b value. Do you see that isn't half the b value positive 2? So it's just x and half your b value squared. See it back here. Isn't this number right here half your b value in that case? It's x with half your b value, quantity squared. So however you want to think of it, it works the same. But uh-oh, look at this. What do these numbers add up to be? -6. Why did I say uh-oh? Because our next move is to square root both sides. And those cancel. X plus 2 comes down, and uh-oh, what kind of answer is this going to be when you square root a negative, real or imaginary? You're going to get some imaginary answers, so plus or minus. And then here's how I roll. I just pretend it was positive for a second. Can the square root of 6, like if that was positive, can that simplify? Or is that as clean as she gets? So that's all you got. But when there's a negative in it, doesn't that mean that an I has to pop out of that situation? So we're going to have I square root of 6 in that case. And then the last move is to finally subtract that 2 over. So x equals -2 plus or minus I square root of 6. And maybe, just maybe, you can start to smell how we're finding these imaginary zeros. There's an imaginary answer right there in that case. So weird. All right, let's pick up the pace. First of all, we cannot factor number 3. Would you believe you can't find two numbers that multiply together to be -7 and add together to be 12? Is A 1? Boom. Is B even? Boom. Please set it up with blanks. Pause the video. All right. So we're going to put 36 in the blanks because that's half our b value squared. And then let's see if we can factor this guy over here. He's a perfect square trinomial. So it's going to be the quantity squared with an x in there, and half your b value. How are you feeling about an x plus 6 going in there? Add these pups up over here. How much is this? 43, is that right? Yes, no, maybe? What's my next move? Square root both sides. I don't care if you put the radicals or if you don't put the radicals. So you're going to have plus or minus square root of 43. And then we got to see if the square root of 43 can simplify. So it is a real number, but let's see if it can simplify. Working backwards, 36 doesn't go in there evenly. 25 doesn't go in there evenly. Does 16 go into 43 evenly? You can always punch it in a calculator if you need to. Nope. Does 9 go into 43 evenly? 4. So this is as clean as she's going to get. But what we got to do to solve, move this guy over. So x equals negative 6 plus or minus the square root of 43. Completing the square. All right, so let's have you try one on your own. Why don't you pause the video and give this one a try. Set them up with blanks, fill in the blank, and complete the square. Check back when you're done. So 16 is a number that goes in the blank. It's got to be positive. Then it factors to be x minus 4 quantity squared equals 26. Square root in both sides. Square root of 26 does not simplify either, so my final move is to add 4 over, and does an x equal 4 plus or minus the square root of 26. Sound okay with that? Let's skip down to, let's skip number 5, just because I don't have it pre-prepared. Let's skip down to, what are the last ones, 6, 7, 8? Let's go to number 7, okay? Skip down to number 7, because I think we're getting it, and let's see how we do. Again, I'm going to have you pause the video, give it a try, see what we do. Okay, so we got started. We filled in the blank with the 25. Remember, we had to add that 7 over. Do a little factoring right here, equals this. And at this stage, I got x minus 5 equals plus or minus the square root of 32. Here's the bad thing. We have to see if the square root of 32 can simplify. There is a perfect square that goes into 32 evenly. So let's think backwards. 36 is too big. Does 25 go into 32 evenly? Does 16 go into 32 evenly? So how many times does 16 go into 32? 2 times. Right? So that means we break them up into 2 radicals. The perfect number goes on the left. How many times on the right? So how do you feel about this turning out to be x plus or minus 4 square roots of 2 in this case? That's really what the square root of 32 is. 4 square roots of 32. That equaled x minus 5. And then would you be cool with the fact that we got to add the 5 over, and then we finally get 5 plus or minus 4 square roots of 2 in that case. So watch to see if the radicals can simplify. That rarely happens when you complete the square. It happens all the time when you use the quadratic formula. If you was to do the quadratic formula, you'd get these big old juicy radicals that you always have to simplify. That's why I don't like using the quadratic formula if I don't have to. So last one of this side, we'll do number 8 for the last one. But before we do it, let's realize again why we're completing the square, besides the fact that it tells you to. Because anybody can do whatever somebody tells them to do. How do you know you're supposed to do it when you're taking the test? That's the question. This is a quadratic equation. It won't factor. You cannot find 2 numbers that multiply together to be 9 and add together to be 4. Cool? So why not use the quadratic formula? Because A is how much? 1, and B is what kind of number? Even. If A is 1 and B is even, completing the square is our ticket, my friends. So let's do it. Set them up with blanks. Move that 9 over so it doesn't become a negative 9. Add a blank over there. Fill in the blank with half the B value squared, which is 4. Are you all okay with that? And then we got x plus 2 quantity squared over yonder. Uh-oh, what kind of number is this? Negative. Would you believe we're going to get imaginary answers then in this situation? Because we got a square root next. So x plus 2 is going to equal plus or minus. When we square root both sides, it's negative. Let me go back and show the baby step. Guess what always has to pop out of there? When you square root a negative, what has to pop out? I's got to So think of them as positive square root of 5. Does the square root of 5 simplify at all? No, it does not. So we'll just call him I square root of 5. Are you all okay with that? The I? Okay, so then x will equal negative 2 plus or minus I square root of 5. So weird stuff, getting imaginary answers. This is a big clue of how we're going to find our imaginary zeros. You know how I told you some of the zeros are real and some of them are imaginary and stuff like that. So, and same thing you do on number 9. But I think we get the idea of how to do it. Well, let's go to the backside. The backside is all using the quadratic formula. Why would we use the quadratic formula on this one? How about the better question is, why not complete the square? Why not complete the square on this one? A is not 1. That's one reason. And would you believe the B value is odd? I will tell you, you can complete the square on this. First, you'd have to divide everybody by 2. Then you'd get fractions in here. And then you have to go through. It's a mess, right, to complete the square on this. But if A is 1 and B is even, it's not a mess. So this also won't factor. I cannot find two numbers that multiply together to be negative 2 and add together to be 7. So quadratic formula is our best bet on this one. So I'm a believer of A, B, and C. I don't care if you do that. It's up to you. You're not a little kid anymore. So A is 2, B is 7, and C is negative 1. When we did the quadratic formula back in chapter 3, though, we totally used decimals for answer. Now no decimals. They want exact answers. So opposite of B, plus or minus, big old honker radical. B squared is 49, down with that, minus 4 times A times C, all of it over 2 times A. I know I put the quadratic formula on the front side. Is it on the back side too or not? Okay, so it's right there for you. You got to get it memorized. Then please, I ask that you show me the work by cleaning up this discriminant. You can use your calculator to do that, but just punch all that stuff in. Negative 7 plus or minus square root of somebody all over 2. I'll let you punch it in for me. Second. So we got a discriminant of 57, which does not simplify. There is no perfect square that goes into it. It's not negative either, so we're not going to get imaginary answers back. So it is a real answer. But thinking back on your list of perfect squares, there is no perfect square that goes into it. So this is it. There's your final answer. Question, though, how many answers are there? One answer or two answers? There are 2 because of the plus or minus. So that one is nice. We also have to check to see if it can reduce in this triangle of death right here. I'd always call it the triangle of death because people have a hard time reducing it, but there are 3 numbers to look at, and there is no number that goes into all 3 of those. We'll talk more about the triangle of death in a second. Say that again. Yes, it should be a 4. I did that both times. Thank you. For everyone out there in video land also, I made a mistake. This number is a 4. Because it's 2 times A, and I, for some reason, just wrote 2 down instead of 4. So thank you for correcting me. 2 class periods in a row messed that up. So you okay with that? Thank you for the correction. Let's try again. First off, major typo on this one. We were talking about why we're not complete the square. Not 1 is not even. You find 2 numbers multiplied together to be 14 and add to be 9? Yes, you can. It's 7. Would you be okay with that? So I don't want to do that one. Let's change this to 10 real quick. Now, there's no way this factors. So everything that we're going to end up using next class period will not be factorable. So let's keep practicing the ones that we can't factor. So we're going to say A is 14, B is 9, and C is 10. And I'm sorry that I messed up last time by doing the denominator wrong. Let's make sure we get our denominator correct this time. Opposite of B, plus or minus, I'll let you put the rest in there. B squared minus 4 times A times C, all of it over 2 times A. So that's going to be 28. Y'all good with the 28? Then we'll punch in this big old honker of a discriminant. It's going to be a large negative number. I can't remember what it is off the top of my head either. So. Negative 479, is that right? So, question, real answers or imaginary answers? Imaginary. I will tell you that the square root of 479 does not simplify either, so, but something has to happen to simplify. We do have to do something. What has to happen? We got to pop out and I. And I's got to pop out. So we're going to call that I square root of 479. So you're never allowed to leave a negative number underneath the radical. You can always simplify an I out of that situation. Then check in the triangle of death. That's these three numbers. It has nothing to do with the radical. It's the 9, the 28, and the 1 that does not reduce. We will see more of that here in a second with the old triangle of death. So, all right. I'm going to let you get started, and then we'll do the finish. This one's really, really weird when we get to the end of it, so let's see what happens. So please pause the video, get her started, and then we'll finish it together once you've got your discriminants. All right, I got down to a discriminant of 75, which means we're going to get imaginary answers, right? But let's think of them as positive for a second to see if that also simplifies. Can you find a perfect square that goes into 75 evenly? Which one? So if you want to go off to the side, you can. You know you're going to have an I popping out of it, right? So then you're going to have square root of 25 times the square root of, how many times does 25 go into 75? 3 times. If you don't need to do this anymore, I don't care about you showing that work. You're not a rookie when it comes to simplifying radicals. Some of you need it, some of you don't. But doesn't that turn into be a 5 right here? Square root of 25 is 5. My pen's not working, sorry. Then there's an I with it, and then the square root of 3. So remember, I comes like after that. We don't say I5, we say 5I. So it's negative 5 plus or minus 5I square root of 3 all over 2. What a mess. But when it comes to reducing what I call the triangle of death, it's these three numbers. There has to be a number that goes into all three of these, and there is one. Even though this is a 5 and this is a 5, this is a 2, there is not a number besides 1 that goes into all three of these. So this is as simplified as it's going to get. Cool. One more, and then we'll end with a real easy one. So let's see what happens on this one. Another weirdo, otherwise we'd stop. So get down to the discriminant level, and we'll finish it together. So go ahead and pause the vid. So when I'm doing my b squared, remember that has to be 9. It's not negative 9. Negative 3 squared is always a positive number. Minus 4 times a times c all over 2 times a. Give me a little help with our discriminant. What did we get for a discriminant? Negative 11. Which, if you think of them as positive, square root of 11 doesn't simplify at all. But something has to happen to simplify this. What do you still got to do? Pop out an I. Right, so I square roots of 11 all over 2. Checking these three numbers here, what I call the triangle of death, nothing simplifies. It's going to happen, though, where you are going to do the quadratic formula, and sometimes you need to simplify. So I just made up some examples. This is like, okay, you went through all the work to do the quadratic formula, and this is what you got. Here's the triangle of death right here. See these three numbers. Is there something that goes into all three of those numbers evenly? Don't worry about the radical. He's got nothing to do with it. Just those three numbers. 6, 4, 8. I don't even care about their signs. What goes into each one of them? 2 does. So let's reduce everybody by a factor of 2. Wouldn't that become a negative 4 right here? Plus or minus. What does the 6 turn into if you reduce him by a factor of 2? 3. And there is a radical 3 that's hanging out with him. And that's all over 2 in that case. Cool. But then people are like, well, can you do that here? This is why I call that the triangle of death. You cannot reduce these two numbers without reducing this one at the same time. What's left, there's not a number that goes into all three of them evenly. So many people love to do that. They just love to do that on this problem. On 15, they're like, watch this, bam, those are gone. It's like you cannot do that. You can't cancel half of this stuff out. There's a third guy here, so let's roll with this. In these three numbers, is there somebody that goes into all of them evenly? Yes. So we will reduce that. 2 goes in each one, so negative 1 plus or minus. Don't worry about the I. What's that turn into? 2I. It's going to be all over 1, which you can either put it or not put it. You don't necessarily need to put it. And then on this last dude, or not the last dude, but the next dude, triangle of death, is there somebody that goes into all three of those evenly? 3. So negative 1 plus or minus 3I square root of 2 all over 4. And then they really try to trick you by making you look at this 6. This 6 has nothing to do with it on this next problem. It's the triangle of death. the number in front of it is a 1, would you believe that you cannot reduce that at all? People are like, well, what about the 12 over 2? Can't you reduce that? You're reducing these and not reducing this. It doesn't work that way in that case. It has to go into all 3 of those. So what are we supposed to put? Simplified. This is as simplified as it already gets. Feel all right with it? Let us know if you have any questions. Have a good one.